In this video, we're going to learn about slopes of lines and y-intercepts. Now, in this first question, we're wondering, what type of slope does the line on the graph below have? So notice we're not looking for the actual slope, we're looking for what kind of slope. So what we're talking about here is that lines that slope up from left to right have a positive slope. Lines that slope down from left to right, those have a negative slope. Horizontal lines, you could say, have no slope or a zero slope. And vertical lines, or perfectly steep, have an undefined slope. In this case, we have a negative slope because the line slopes down from left to right. Now here we need to find the slope of the line. Now there are different ways of describing the slope. Now one way is to abbreviate the word slope with the letter M. We use the letter M to abbreviate for slope. Now we can also say the slope is the rise over the run. So in other words, we're wondering how far up or down do we go as we go to the right. Now some other ways to describe the same thing. The slope is the change in y, or delta y, over the change in x, or delta x. And one way to calculate a change like this is to subtract. So for instance, we can take the second y, subtract the first y, take the second x, and subtract the first x. Now in this case, we have a graph to look at. So we're going to be looking at the rise over the run, and we're going to be moving from the left to the right. So let's find two good points here. Here's one right here. This happens to be the y-intercept, but it doesn't have to be. And I'm going to slide along this line until I run across another perfect point where it hits two grid lines. And here's a perfect point right here. All right, so from this first point to the second point, we go up and over. And in particular, we went up 1 unit and over 2 units. Notice I'm counting spaces. So the slope of this line is up 1 over 2. Notice I put the rise, or the change in the y's, over the run, or the change in the x's. Here we have a line with a negative slope. Let's go ahead and find two perfect points. Here's one at the y-intercept again. That point's at -4. And I'm going to slide to the right until I find another perfect point. Well, here's one right there. So going from left to right, I'm going to go down 2 and right 1. So the slope is, let's see, down 2, right 1. So the slope equals -2 over 1. That's the down 2, right 1. And whenever we have 1 in the denominator, we can just get rid of that. So this is -2. So your slopes don't have to be fractions, but if our slope is an integer like this -2, we understand there's a 1 underneath there. So this wouldn't mean go down 2 over nothing. It would mean go down 2, right 1. Here we have a line that has no steepness at all. It's perfectly flat. So in this case, we say that the slope equals 0. So the slope of a horizontal line is 0. If we have a vertical line with perfect steepness, well, we say that has an undefined slope because we don't have a number to describe perfect steepness. So we just say undefined slope if it's vertical, like this one. Horizontal, slope is 0. Here we have to identify both the slope and the y-intercept. Well, let's see, here is the y-intercept. That's at -2. The y-intercept is where the line or the graph crosses the y-axis. Notice the x value of this point is 0. All right, and the slope of this line, let's see, we need to go down and right. I'm going to slide along this line until I run across another perfect point. And I found one right there. So I need to count how far down and how far right. So I'm counting spaces. 1, 2, 3, 4. So I went down 4, and looks like we're going right 5. 1, 2, 3, 4, 5. So the slope of this line is -4/5. Down 4, right 5. Now here we don't have a graph to help us. Let me make a quick sketch though, just so we have a rough idea what we're talking about here. Let's see, 8, 6, that would be maybe over here, and 2, 3, that might be here. So we're looking for the slope of this particular line. Now in this case, when we just have the coordinates, we can go ahead and use the slope formula. So we have y2 minus y1 over x2 minus x1. Now this really means the second y minus the first y, and the second x minus the first x. And what I mean by that is in this first point, we have the first x and the first y. In the second point, we have the second x and the second y. So let's carefully put these pieces into the formula. All right, the second y is 3, and the first y is 6. The second x is 2, and the first x is 8. 3 minus 6 is -3. 2 minus 8 is -6. Negative divided by negative is positive. We can divide both of these by 3. So this would be 1 over 2. I guess another way to look at that is we're dividing both of those by -3. So we have a slope of 1/2. Looking at our sketch, that looks about right. All right, let's see what we have here. The Canadian Census Agency predicted that the population of Ontario would be about 33.4 million in 2010, and increase by 2.3 million per year until 2030. In this situation, what is the value of the slope? Well, fortunately here we don't have anything to calculate. We're looking for the rate of change. Now, the 33.4, that's not a rate of change, that's just how many people there are in 2010. But here we're increasing by 2.3 million people per year until 2030. So here is our rate of change, which is the slope. So here we kind of get a glimpse of the importance of slope, because it's really describing these rates of change that are so important everywhere. Doug is taking a long-distance trip in his car. The following graph models the relationship between the number of gallons in Doug's car, that's on the y-axis, number of gallons, and the number of hours Doug has been driving, that's on the x-axis. What is the correct interpretation of the y-intercept? Well, the y-intercept is where the graph crosses the y-axis, so that's up here at the number 26. So the value of the y-intercept is 26. Well, what's the interpretation of that 26? Well, the y-intercept happens when the x value is 0. So in other words, we're at 0 hours at this point. This is the point 0, 26. Well, when Doug's been driving 0 hours, he's at the starting location. And the 26, that's how much gas is in his car. So when Doug starts driving, he has 26 gallons of gas in his car. All right, here we need to find the slope and y-intercept of the line that passes through all the points on the table. So if we were to graph these points, we're wondering what the slope and y-intercept of that line would be. Well, let's see. Let's start with the y-intercept. The y-intercept occurs when the x value is 0. Because when you're right or left nothing, you're on the y-axis. Well, look at this. We are fortunate enough that this table has included a line that shows us what the y value is when x is 0. So the y-intercept is 20. This line would go through the point 0, 20. All right, we also need to find the slope. Now, let's see, they told us this is a line, so we can pick any 2 points we want to. So we might as well pick 2 that don't have any negatives in them. And we'll find the difference in the y's and the difference in the x's. All right, so I've picked the point 829 and the point 1638. All right, the slope is equal to the second y minus the first y over the second x minus the first x. Let's see, why don't we go ahead and write points out of this? So we have 829, that would be the point for this line, and 1638. So this would be the first x and the first y. And this would be the second x and the second y. Okay, so we have the second y minus the first y over the second x minus the first x. All right, 38 minus 29 equals 9. And 16 minus 8 equals 8. So the slope is 9/8. And finally, we need to identify the slope and y-intercept of this line. Well, the y-intercept, that's right here at +1. It's where the line crosses the y-axis. And for the slope, we might as well start at this point. I'm going to slide down this line until I hit another perfect point, and I hit one right here. So I go down 1, 2, 3, 4, down 4 over 1. And that's the same thing as -4. So the slope of this line is -4. All right, I hope these examples have been helpful. This is Mr. Ela signing off.